Hello students, in my last video we have read about what are colloids, characteristics of colloids such as nature, particle size, separability, settling of particles, Tyndall effect, dispersion medium, dispersed phase, and then classification of colloids based on physical state of dispersed phase and dispersion medium, in which gel, sol, and emulsion are very common. The second classification was based on the nature of interaction between dispersed phase and dispersion medium, under which we have seen lyophilic colloids and lyophobic colloids. In continuation with all these things, for today we are going to learn about the third classification of colloids is based on the type of particles of the dispersed phase. There are three types. Number one is multi-molecular colloids. And the second one is macromolecular colloids. The third one is associated colloid or micelles. Let us check what is multi-molecular colloid. These are colloids which are formed by aggregation of many small atoms or molecules whose size is less than 1 nanometer. For example, sulfur salt or gold salt or platinum salt. Once again, let us examine what are multi-molecular colloids. In the screen, what you can see is S8 molecules, which are having a size lesser than 1 nanometer. When thousands of S8 molecules combine or aggregate, it forms a sulfur salt. Now, if you look at the size, it is bigger than what it was earlier. So this is how the multi-molecular colloids are formed. Next is macromolecular colloids. Macromolecular colloids itself indicate that they are big enough, such as starch, cellulose, enzymes, all polymers. Once if you dissolve it in a suitable solvent, that's it, your colloid is ready. You all would have heard about dual personality. Even associated colloids are considered to have dual character. Hence, they are also called as dual character colloids because at lower concentration they behave as strong electrolytes, but at higher concentration it aggregates to reach a colloidal range. This is called associated colloids, and they are popularly called as micelles or ionic micelles. Examples are soap in water or synthetic detergents dissolved in water. Let us have a small idea about associated colloids now. Soaps are generally represented by a formula RCOO minus Na plus. At lower concentration, it behaves like a strong electrolyte. Hence, it splits to give you RCOO minus plus Na plus. Now this RCOO minus can even be represented pictorially like this, in which the zigzag portion is called as tail which is hydrophobic in nature and it is non-polar in nature. Whereas the red color region is called as head, which is polar in nature and it is hydrophilic in structure. When you have the higher concentration, the soap molecules will come close to each other to form a spherical structure called micelle or ionic micelle or associated colloid. There are a few more things you have to understand and remember. The first point is Kraft temperature. Association of colloids will not happen in all the temperatures. There is a specific temperature for it to happen, and that is what we call as Kraft temperature, and it is represented by capital T subscript small k. And then the second term which is associated with the micelles is critical micelle concentration. For a micelles to form or associated colloids to form, we need certain concentration to come into a play, and that concentration is called as critical micelle concentration. For example, the critical micelle concentration of a soap when dissolved in water should fall between 10 power minus 4 to 10 power minus 3 moles per liter to form an associated colloid or micelles. Let us look into the detail of mechanism of micelle formation. Soap is a sodium or potassium salt of higher fatty acids, and it may be represented by a general formula, as we all know, RCOO minus. Example for soaps are many, in which to mention sodium stearate or potassium stearate are very, very common. Here is a soap which is sodium stearate, and it has a formula of C17H35 COO minus Na plus, which is going to be the major component of many bar soaps and soaps. When dissolved in water, they dissociate to give you this as one portion. Along with that, Na plus will also be present. If you look at the structure of this portion, it is a tail and it is hydrophobic in nature. And here the COO minus group is hydrophilic in nature and it is going to serve as a head, and this can be simply represented like this structure. In RCOO minus, since the R group is hydrophobic in nature, it remains at the surface, and COO minus being hydrophilic in nature, it remains inside the water. This minus indicates COO minus. At critical micelle concentration, anions are pulled into the bulk of the solution and aggregate to form a spherical structure or a shape in which hydrocarbon part pointing towards the center of the sphere with COO minus part remaining outward. Micelles may be made up of more than 100 units like this. Similarly, in case of detergents, example sodium lauryl sulfate, the polar group is SO4 2 minus along with the long hydrocarbon chain. Hence the mechanism of micelle formation here also is same as that of soaps. Here is a cloth which has a grease on its surface. The cleansing action of soap is due to the fact that the soap molecules form micelle around the oil droplet in such a way that hydrophobic part of the stearate ion is in the oil droplet and the hydrophilic part projects out of the grease droplet. Since the polar group can interact with water, the oil drop gets surrounded by stearate ion, is now pulled into the water and removed from the dirty surfaces. Thus, soap helps in washing away the oil and fats. The negatively charged sheath around the globule prevents them from coming together and forming aggregates. Students, let us look into the preparation of colloids. The first method is a chemical method. Chemically, the colloids can be prepared by various reactions such as double decomposition, hydrolysis, reduction, oxidation, etc. Let us see the double decomposition reaction first, in which arsenous oxide and hydrogen sulfide, both of them undergo for a decomposition to give arsenous sulfide salt, and the side product in this reaction is H2O. The second method is oxidation, in which the sulfur which is present in -2 oxidation state here gets oxidized to 0 oxidation state. In this reaction, the side product is water. And the next reaction is a reduction reaction by which the colloids are made. In this reaction, gold 3 chloride, that is a gold which is present in +3 oxidation state, gets reduced to 0 oxidation state. In this reaction, formaldehyde acts as a reducing agent, which in turn oxidized to give you a formic acid, along with the 2 molecules of water is formed as a side product. And the fourth method of preparing a colloid chemically is hydrolysis. When FeCl3 undergoes for hydrolysis. Otherwise, when FeCl3 is boiled with water, it undergoes for hydrolysis to give you FeOH thrice salt and 3HCl as a side product. There are so many ways to make a colloid. The second method is called Briggs arc method, is also called as electrodispersion method. Widely used in the preparation of colloidal solutions of metals such as gold, silver, platinum, etc. This method uses 2 rods of metals which we want to disperse as electrode. Rods are immersed under the dispersion medium. In this case, water along with some stabilizing agent like potassium hydroxide is used. The whole set is placed inside the ice bath or cold bath to have better cooling. Ice is mixed with NaCl. When electrodes are charged using electricity, arc is formed at the end of electrode. Due to the arc, huge amount of heat is produced, causing a metal to vaporize Since the water is still cold, metal immediately condenses back to form solid and disperses to form a solution. The third method for the preparation of colloids is peptization. The process of converting a freshly prepared precipitate into a colloid particles by shaking it with a small amount of suitable electrolyte is called peptization. And the electrolyte which we are going to use for this purpose is called peptizing agent. During peptization, what happens is the precipitate absorbs one of the ions of the electrolyte on its surface. This causes the development of positive or negative charge on precipitates, which ultimately breaks up into smaller particles of the size of a colloid. Colloids which are prepared by any of the above methods used to have some impurities in it. Hence, it is very important to know the methods which are employed for the purification of colloidal solutions. Colloidal solutions, when prepared, generally contain excessive amount of electrolytes and some other soluble impurities. Presence of electrolyte is essential for the stability of colloidal solution, but larger quantities may coagulate it. So the process used for reducing the amount of impurities to a required minimum is known as purification of colloids. The purification of colloidal solutions is carried out by the following methods. The first one is dialysis. The experimental setup used for the dialysis is visible on the screen. Dialysis is a process of removing dissolved substances from a colloidal solution by means of diffusion through a suitable membrane. Ions are smaller molecules in a true solution can pass through the animal membrane or bladder or parchment paper, but not the colloidal particles. The apparatus used for the purpose is called as dialyzer. Here, what happens is a bag of suitable membrane containing the colloidal solution is suspended in a vessel through which fresh water is continuously passed. Fresh water is continuously passed. The molecules and ions will pass through the membrane into the outer water, and pure colloidal solution is left behind in the bag. But the problem with this purification technique is it is going to be very, very slow. Hence, if you could keep electricity for the same setup, the process can be made fast. Hence, the second technique available for the purification of colloids is electrodialysis. The apparatus is same almost, except we have electricity here. It is the process of removing a crystalloid from a colloidal solution using suitable membrane under applied electrical field. The next technique is ultrafiltration. We have several types of ultrafiltration. Anyway, it is the process of purification of colloidal particles using ultrafilters. Now there will be a question, students, what is ultrafilters? Ultrafilters are prepared by soaking the normal filter papers in collodion solution and hardening by formaldehyde and then finally drying it. Then you will be having a question, what is collodion? Collodion is 4% solution of nitrocellulose in a mixture of alcohol and ether. Students, do you all know where the ultra filters are used in a day to day life? They're actually used in water purifiers.